Hello, this is Mr. Win, and this video is about graphing two variable inequalities and finding inverses. So to graph a two variable inequality, your first step would be try to get it into y equals or y less than y greater than form. You want y by itself, unless it's standard form for a linear, for a line. But once you have that, you can sketch it like a transformation. Look at the AHK, and then once we have the picture, we use a test point to figure out where to shade. So make sure you see if the line is solid, closed, or if the line will be dotted or dashed because it's open. Also remember, there's always one area shaded. So your test point doesn't have to be in the correct spot. We have to test a convenient point. Alright, and for a line, there's a top area and bottom area, or sometimes you can say left area and right area. But for weirder shapes, like U's and V's, the parabolas and the absolute value, there's inside the V and outside the V. And lastly, if they ask you to see if a point is a solution or not, you have two options. The longer option is graph the whole thing and see if that point is obviously in the shaded area. But we're sketching, so sometimes it's too hard to tell, too close. So the second option, the smarter one and the fast one, is plug the point into inequality and see if it's true. If it's true, it's correct. If it's false, that's not in the correct area. It's not a solution. Alright, so first is graph y is less than or equal to 2x plus 5. Well, I know that's, let me do the HK way. It's linear, that's the type. It's a diagonal line. The A is 2. 2 is once it's vertically stretched by a factor of 2, and then it's up 5. And also this line is solid. Alright, that's all you need to know to graph this picture. So I'm going to draw my coordinate plane. I'm going to start from 0, 0. I'm going to go up 5 right here. That's 0, 5. You should label it. And then I'm going to draw a diagonal line, but instead of a regular 45-degree angle, I'm going to stretch it, make it taller. So it'll look like this. There's my picture. So done. Now do the shading part. So I'm going to pick a point that's obviously on one side or the other. Now the safe points are directly above, below, to the left or the right of your starting point. 0, 0 is totally safe. It's on the bottom side, or you said the right side. I'm going to plug it in to the original equation. So it'll be 0 less than or equal to 2 times 0 is 0 plus 5. That's why 0 is the best, because when you multiply by 0, things go away. So I finally end with 0 is less than or equal to 5. That's true. Since that's true, the side where 0, 0 is correct. This whole right side is shaded. Done. I graphed my picture. Now, is 10, 3 a solution or no? So I'm looking at my picture. Is 10, 3 obviously in the shaded area? Yes, it is. Because if this is 5, the height's 5, 10 is somewhere over here. I'll use blue. 10 is somewhere way out here, but 3 is below 5. This is 5, 3 would be somewhere down here. So yes, it is in the correct area. So that's true. So the answer is yes. But let's prove it by just plugging it in. So if I plug in 10 for x and 3 for y, I get this. And I'll use red. So 3 for y is less than or equal to 2 times 10 plus 5. I'm going to simplify. That's 20 plus 5. 3 is less than or equal to 25. That is true. Since it's true, that is a solution. I'll do the same thing over here. Now our equation is on the correct form. So I'm going to solve for y. So let me do this. So first, I'm going to add x to both sides. So 2y is greater than x plus 4. Alright, then I have to divide by 2. So y is there's x plus 4 over 2. Actually, you want to split this up. If you have a big fraction like that, just divide each numerator by the denominator. This is x over 2 plus 4 over 2. And actually, 4 divided 2 is 2. Now I'm going to write like this. 1/2 x plus 2. Alright, now I kind of see the AH and K. So from here, I can say, well, this is a line. It's linear. The diagonal line. The A is 1/2. That's less than 1, so that's vertically compressed. It'll be flatter and wider. There's no reflecting. Let's see, that's no H because there's no parentheses. That's K, the plus 2 is by itself. So that's going to be up 2. And this graph is dotted or dashed. I'll say dotted because it's open. So from there, I can graph this. I have all the information I need. So from 0, 0, I'm going to go up 2. Let's do that. That is 0, 2. I'm going to draw a diagonal line. But instead of a 45-degree angle, I'm a vertically compressed. I make it wider. And it's going to be dotted. So here you go. Alright, but it's not a regular diagonal 45-degree angle. Now I do a test point. Oh, 0, 0 is obviously on one side, so that's good. I'll use it. But I don't have to use 0, 0. I could use, if I wanted to, I could use 5, 0 or 1, 0 or something way down here, negative 0, negative 5. But any of those would work as test points. All right, by plug it in, let's see what happens. I'll plug into the original equation. You could use this equation right here, but the original is really nice, especially for standard form, because we have standard form. Negative 0 is just 0, plus 2 times 0 is 0. It's greater than 4. 0 is bigger than 4. That is false. So my test point 0, 0, or any other point I picked down there was not true. That's the wrong side. So instead of shading the bottom, I'm going to shade the top. So everything up here is a solution. All right. And the other question is, state is negative 6, negative 1 a solution or not? Now, negative 6, negative 1 is left 6, down 1. I don't know where this point is. So it's too close to tell. I don't know where the x-intercept is. So here I have to just plug it in. I can't just assume. Because negative 6, 1 could be right here, or it could be right here. We don't know. Negative 1. So let's plug it in. Let me undo those 2 points. All right, so if I plug into the original problem, negative 6, that's what x is, plugging x, plus 2 times negative 1 is to be greater than 4. That's just positive 6. Negative 1 times negative 6 is positive 6. Minus 2 is greater than 4. 4 is greater than 4. Nope, there's no equal sign. That's false. So nope, not a solution. In this case, it wasn't on either side. It was actually on the line, on here. If it's on a dotted line or dashed line, that doesn't count. It has to be a solid line for it to count. That's why we say it's not included, because it's open. All right, we'll do the exact same thing for absolute value. So we see the type, the bars. That means absolute value. It's a V shape. I'll do that, absolute value. There's a 2, that's a multiplier, that's A. That's vertically stretched, so taller and skinnier. And that plus 3 is the K, that's up 3. And this is closed, so it's solid line. I'm going to draw my graph. I'm going to start at 0, 0. I'm going to go up 3. I'll put a dot there. 0, 3. I'm going to draw a V, but instead of 45-degree angle V on both sides, I'm going to make it skinnier and taller. I'll shoot up like this. So it's a thinner V. All right. Now do shading. Well, 0, 0 is on the outside, so 0, 0 is safe. But again, anything to the above, below, left, or right, it has to be obvious. If it's touching the line, you can't use it. I'm going to plug in 0, 0 to the original problem. 0 for y, that's equal to 2, absolute value 0 for x, plus 3. Well, this comes out positive 0. 2 times 0 is 0 plus 3. 0 is less than or equal to 3. That is true. So the side with 0, 0 is correct. That's everything outside this V. So all of this is the answer. All right, now they ask, is 10, 3 a solution? Yes or no? Well, 10 is way out here somewhere, and if that's 3, it's right here. That is definitely outside the V, so this is a yes. It is. But we can also check if we can't tell. So let's plug it in to the original. So it'll be 3 for y, 10 for x, plus 3. Well, you do absolute value first. It comes out positive 10. Then I can multiply. That's 20 plus 3. That's 23, and that is true. So yes, the solution. All right, same thing over here. It's absolute value again, V shape, absolute value. A 3. 3 is more than 1, vertical stretch. That plus 1 is inside the bars with the X, that's the H. And there's opposite, so instead of right one, I think left one. And this one's open, so it's going to be dashed or dotted. That's all the information I need. So I'm going to draw my axes. From 0, 0, I'm going to go left 1 right here. Let's call that a 0. Sorry, left 1 is negative 1, 0. Then I'm going to draw my V, but skinnier. So I'll draw a really tall V. All right. I need to do a test point. 0, 0 is on the right side, so it is safe. But let's not use 0, 0. I'm going to use 5, 0. Because I don't want to be too close to the V. So if I plug in 5, 0, I'm going to see if this test point is true or false. If it's true, in the correct area, shade there. If it's false, I'm in the wrong area, I shade the other area, which would be inside the V. So 0 for y, 5 for x, 0 less than 3, that's inside 6. It comes out positive 6, That is 18. 0 less than 18. That's true. So this is the correct area. All right, is 110 a solution? Now, it's not obvious. I don't know if 110 is over here inside or if it's outside. So again, our graph's not drawn to scale. That's a shortcoming, weakness of a sketch. So we have to plug it in. So I plug in 10 for y and 1 for x. All right, do the inside. That's 2. It comes out positive 2. I multiply 6. Is 10 less than 6? No, that's false. So this is not a solution. All right, so that's how you graph two variable inequalities. All right, the other part of the video is inverses. Inverses are obtained when you flip the x and y's of all coordinates. So if they give you a table right here, if we have the original point 1, -2, we take the inverse. We just flip it. So instead of 1, -2, it'll be -2, 1. Here's the new one. So I just reverse all the points. All right, on a graph, if I graph all those points, you will see the picture. They're the same triangle, but they are kind of turned, or actually inverted is the word. And they should be mirror images of each other, but reflected across the diagonal line y equals x. All right, so basically you can fold them over that diagonal line, and they should overlap perfectly. All right. Now, for equations or functions, if we have the function f of x, we call it f inverse of x. Now, that's not a -1 exponent. It's just how we write it. But there's an algebraic method to find the inverse. And it's basically the same thing you do. We're going to get the equation to y equals. Sometimes it's already y equals, sometimes it's not. Then, like before, we're going to switch all x's and y's. We're flipping it. And then you're going to solve for the new y. So here it says find the inverse of f of x equals 2x minus 5. I want to flip x and y's, but I don't see y yet. So I'll change this to y. So step 1, done. Step 2 says flip all x's and y's. So this is now x, and this is now y. Step 3, the long step, is solve for y. I'm going to add 5 to both sides. Then I'm going to divide by 2. I'm done. Now instead of calling the right side y, we create a y in the problem. Let's put it back. So we'll say x plus 5 over 2 equals f inverse of x. So that's the inverse. All right, and that goes right here. So x plus 5 over 2. It's a pretty short 3-step process. And the last thing is this: if you compose a function with this inverse, you'll get back the identity function x. This is used for verifying if two functions are inverse or not. You could also just pick one and find the inverse and see if it matches the other. But here's what I mean. We did compositions in the earlier video. So we'll do this, and you'll see it'll come back out. So I'll do one of them. Like earlier, the last problem we did was this. So I do know these are inverses, but I'm going to prove it to you by doing composing them. So the first one says do f of f inverse of x. Well, to do f inverse of x, that means go to the equation f inverse and plug in x for x. Well, that's really no change because there's already x there. So that's going to place it inside. So this turns into f of x plus 5 over 2. This now tells me to go to equation f and plug in x plus 5 over 2 for every x. So this will be 2 times into the x, but x plus 5 over 2 minus 5. If you notice, these 2's cancel out because it's a fraction. So this will be x plus 5 minus 5. If I combine like terms, this will be x. It's 5 minus 5 is that. So this turns to x, and we're good. It came to the original thing. I do the same thing for the opposite. So let's reverse it. So f inverse of f of x. This first one tells me to go to f of x. I'll go to equation f, plug in x for x. That's no change. So done. I'll now do f inverse of 2x plus minus 5. So that tells me to go to equation f inverse and plug in 2x minus 5 for every x. So I'll be 2x minus 5 plus 5 over 2. If I simplify the top, that'll be 2x minus 5 plus 5 cancels out over 2. And 2x divided by 2 is just x. So that's also x. So if you compose them both ways, they go back to just x, where you plugged in. So for inverses, order does not matter. That's it for the video. Hope you enjoyed it. Make sure you ask any questions in class. See you soon. Bye.